Hi, my name is Mike Wytrzyszczewski. I am the Construction Division Manager with the City of Akron. I'm here today to talk to you about one of our basins that we have built as part of the AWR program. It's a citywide program. It's a $1.2 billion program. This is one component of it. What you're looking at here and what you're going to see is a basin that is intended to hold combined sewage overflow, or CSO as we call it. The general idea here is to store as much wet weather flow. When it rains, our sewers become taxed, and we have to store the CSO in these tanks. The idea is to hold it until the rain event is over and then release it back into the sanitary sewer system to be treated at the plant. Now, if there is a rain event that exceeds the amount of flow that's capable, this basin will overflow, and I'm going to show you a little bit of how this operates. So what we have here in general are two channels to start with. We'll get to the bigger part of the basin here in a minute. What you see on the left channel is what we call the big. It's the Basin Influence channel. During dry weather event like it is today, the sewer is underneath, as you can see. So there's a pipe underneath there that carries it down to the sanitary sewer, which actually flows right along the river, which is behind us currently as we stand here. As the weather changes and the rain starts to come up and our sewers start to fill, this chamber here on the left, this channel, will start to fill up with CSO. Now remember, CSO is combined sewage overflow. It's about 95% water, but it does have sewage in it, so we have to deal with it. As it starts to come down into this channel, there's what you see down here. It's hard to really see, but there's panels here. Underneath there is a screen. Now it's a lot like a bar grade screen, and what that's meant to do is the flow is coming up through that screen, but the solids are kept down into the sanitary sewer to be treated. Now it doesn't catch everything, of course, but it does catch over 95 to 98% of the flow, getting solids like cups and things like that. So what happens when these things start to fill up? Well, on the wall on the left, as you can see, there's a wall. There's a wall in the middle too. So when this thing starts to overflow, they'll start overfilling into the basin, which is to your left. And there are two main cells in this basin. The reason for the cells is there's no reason to fill it up if we don't have to. As you can look through there, there's the middle wall there that has a lower elevation than the wall we were just looking at. It's also notched out. So as cell 1, which is the one closest to us, starts to fill up, it will then go over to cell 2. Everything is sloped. This is a gravity in, gravity out situation. So the idea here is no pumping, no pumps needed for this basin. As I like to always say, gravity always works and it's always free. So we always try to do gravity whenever possible. Now panning back over here to the left. So when let's say the rain event is more than a typical year, which is what our baseline design is with. The idea here is that steel plate, the flow will come over and to the right into this other channel. This channel here that's currently being cleaned out is what we call the overflow channel. When the rain exceeds the typical year, in theory this is going to overflow, and then this channel goes directly to the river. All right, so we're back, and what I want to show you here are a couple of components that make this basin try to be as low maintenance as possible long term for our sewer guys. So one of the things you see over there on that far end are those silver canister looking things. What those are, they're called tipping buckets. And what they're meant to do is actually flush out the basin on the bottom, on the slab, and force everything down to the one end here, as you can see. And today, we're kind of lucky, I guess, in a way, that we're actually seeing this dewatering happen. Cleaning. You do see some floatables in there. Those will go down to the treatment plant to be picked up. Right now, it's just draining. So this is just some overflow from the base, or the hydrants that we are using to clean it today. But those tipping buckets work much like a water park when you see those big buckets. at the water park that your kids go to. They tip eventually and they all just swoosh the water down, and it's very, very effective. The whole thing is designed to do that. That's why you see these curbs in there, to keep everything hydraulically in a good place for the water to move all the material down to one area to be cleaned and sent down to the plant. This water right here that you currently see will not go into the river. That is stuff that is going down to the treatment plant. They're just dewatering it right now. Some of the other things you see there are ladders. They actually float up as the water comes up. These are suction lines for water and for bypass pumping if needed, more for emergency. What you see over there is on the side is that red and blue thing. That's a water cannon. We have those placed around the basin, and those are meant to pick up anything that we can't get with the flushing buckets or the tipping buckets, and it's meant to push everything down manually and or through a fiber optic system that we have installed all the way down to the treatment plant. There's a lot of technology in this. It looks fairly simplistic, but there is technology in the building, which we will go to here in a minute. It's pretty basic. It makes basically the gravity system work in our favor. Doesn't need any pumps, electric, or anything like that to be a problem in the future. One of the more important things here is this is a backup generator. It doesn't look like a lot, but it does a lot of functions. In case we do lose power, which happens time to time during storms, as everybody probably understands. This here is meant to run our entire system here, which we'll show you shortly out in the main part of the room. But this is an emergency generator. It runs off natural gas. So anytime the power would go out, this kicks in, and we do exercise this regularly. It's an important part of what we do here on this particular basin, and this is true for all our pump stations and all of our other basins. It's a requirement. It's absolutely necessary to keep the sewage flowing in a lot of cases. In this one here, it's more about gravity, so we only use it for controls, things like that, but it does allow us to run even when there's no power. Okay, so we're now in the control room. I am not an electrician, but I do know what these are the controls. And so what we're looking at here is the actual touchpad that we can use that our people have programmed. And what this does is allows us to control all those components we talked about outside. The water cannons, the tipping buckets, the pumps, anything there, the level sensors that we had looked at when we were outside. So this is the control panel for that. This is run remotely from the treatment plant. It's through fiber optics, so it's real-time controls. We have data that's being collected every second of every day. All that data ends up helping us out. So what you see here is the power panels coming into the station itself. Nothing more than switchgear and a lot of controls. They're all coming back through this what we call our program logic control panel right here. We call them PLCs for short. This really is the brains of the system. This is the electric part of the system that feeds the brain. So both are very highly important. We protect these obviously with a locked building and masonry walls. So very important to have this operational. And if we have to, we can run manually on this station. We don't need the controls, but obviously that's a fail-safe measure. So the last part in the building here, just some operational things. We do have a large industrial dehumidifier that's meant to protect our electronic equipment. We do have an air pump here, allows us to run our pneumatic controls. Brake tank for the water, so there's no possible infiltration of backflow of sewage into the water system here. It physically as possible. That's what happens here. This is also our backflow system for the potable water that comes in. This water is the water that feeds those water cannons outside. These are all meant to protect the water supply again. These are our main control panels that shut off power, and our hydraulic lines here that run those tipping buckets that we talked about outside. They're automatic or hydrostatic controls using hydraulic fluid. And that's the control panel for this. Again, everything goes back to the main panel for informational purposes to feed into the plant. So this is really what we're about. This is what our whole program is for, to clean the waterways. It's literally in our titles. What's really important to all of our engineers, I shouldn't say most, all of our engineers, everything we do, even before this program, was talking about separating sanitary and storm, try to eliminate any type of sewage that flows into the river, any type of trash, anything like that. The important part to also remember, the program is not designed for flood control. It is really about the waterways. And what you see here is where the confluence of the canal, Ohio Canal, and the Little Cuyahoga River come together. It's right downstream of the mussel store. This really is a nice view of what we anticipate all the way through our reaches. We're also performing numerous river restorations as we move along on these projects to better improve the quality and habitability for the wildlife within the stream. And those numbers are coming up dramatically. We just had our 50-year anniversary last year, and we've seen some really amazing results over a long period of time, thanks to many, many engineers, contractors, citizens advocate groups, taxpayers. Everybody has to drink water, and it needs to be clean. So that's why we're here, to prevent erosion of our waterways. Well, thank you for taking this tour today. I hope you found it informative. This is our Rack 22, or our Howard Street Basin. It is at the corner of Howard and Cuyahoga Street. Really, this catches a little bit of the North Hill area. It's meant to hold 2.4 million gallons of CSO. And we appreciate you taking an interest in this. This is all of our money. We think we're good stewards of it. We're trying to do the right thing and make the right environmental choices and get the best dollar value we can for our taxpayers' money. And again, thank you for having an interest. If you please contact the AWR department or the AWR team if you have any further questions. It'll be on the website or on the video. Thank you.